it's me again, and we're going to talk about displacement and volume. So we talked a little bit about volume when you have a rectangle and you go volume equals length times width times height. But what happens if you have a liquid? So you probably have some of these containers at home, and they measure capacity right on them. It's pretty cool. You can look right here, and this says 1 liter. So 1 liter is 1,000 milliliters. If you need a visual of a milliliter, think of those little tiny cubes that we use in class. That is the equivalent of 1 milliliter. And so 1,000 of those would fit into one of these milk jugs. So I'm going to show you a little bit of milliliters versus liters in capacity, and then I'm going to show you displacement. And so if you have a regular pop can at home, you will be able to see right on the side there, it's 355 milliliters. So in theory, 355 of those little cubes would fit into this. Obviously, it's rounded, and so it needs to be able to measure liquid and not solid. So if you remember, capacity is liquid, volume is the actual solid structure, like a rectangle or something like that. So 355 milliliters, that's the capacity of this container. This coffee cream container is 473 milliliters, so about half of this. 473 milliliters. So this one has a greater capacity than this. Then we get into 1 liter or 1,000 milliliters. And finally, you might have one of these kicking around, a bigger milk jug, and those are 2 liters. So please find some of these at home and see if you can look at what the capacity is of some of these common household items. Now we're going to do displacement. And so displacement is when we have an object that is, we can't use volume equals length times width times height, and we don't have a nifty container like this that tells us what it is. For example, a hockey puck. I wouldn't be able to find the volume of this. It doesn't have milliliters or liters on it, so there's no capacity. It's not liquid. And I can't use our formula. So I can use what's called displacement, and I want you guys to try this at home. So what you need is an object like this that's water resistant and sinks, and one of these nifty Pyrex or measuring containers. You probably have one at home, or your mom does. And so if I look at mine, on the side of it, it has milliliters. And so it's a little bit hard for you guys to see, but when I set it flat on the ground, and here, I will adjust this a little bit. All right, when I set, I'll keep adjusting. So when I set it here, it has 300 milliliters in it, okay? What I'm gonna do is I'm going to add my hockey puck to the water. What's going to happen is the water is going to rise. This happens when you jump into the bathtub, and it happens when a bunch of people jump into the pool. Water rises. And so if I drop the hockey puck in here, you can see the water rises. And now if I look at it, the line is at 450 milliliters. It went from 300 to 450 milliliters. And so what that means is the displacement, or the volume of this hockey puck, is 450 minus 300. So it's 150 milliliters. And we know that 1 milliliter equals 1 centimeter cubed. And therefore, the volume of this hockey puck is 150 milliliters cubed. All right, I'll try to get this back up. Here I am again. All right, so that is volume and displacement. I'm going to hit